There we go. So red, blue, total, right? And this is before, right? And then let's go the same thing, right? Red, blue, total. Okay. And then let's go X and Y. No noising. What are you doing back here? What's going on? All right. I'm still, I believe, in the frame of the video. Okay, this is good. Okay, so red, blue, total. And this is going to be after. Yeah? Are we good so far? Now, I've got the calculation of red before. Okay? So red before in the X direction, because that's definitely in the X direction, is 0.2 kilograms times 9.00 centimeters, right? Divided by 7 times 0.04, right? And I can calculate this. I am calculating this. So 0.2 times 9.00 divided by parentheses 7 times 0.04. And when I do this, I get, my answer that I get is 6.43. And this is literally kilogram centimeters per second. It is okay to do your calculations in the same units. Even on the sheet it says do them in kilogram meters per second. Ignore that. Just do kilograms centimeters per second, because why not? Okay. Now, any guesses what the blue momentum was before the collision? It wasn't moving, correct? By the way, if it is moving, if somebody tweaks with that momentum, just go in there. I can show you how to just change it back to 0. This should have been at rest. How about the Y direction? Was the red thing moving in the Y direction? No, it should not have been. If it was moving in the Y direction, make it so that it's not. We're trying to make this as simple as possible so we have only X momentum, right? And then if we add this up, 0 plus 0 is 0. This plus 0 is 6.43. Now, we think that those guys are going to be about the same, yeah? So let's just check our calculations. Let's check our calculations, okay? So red after is going to be 0.2. That's kilograms, right? 0.2 kilograms times 10.28 centimeters, right? So I'm just looking at the diagram there, right? 10.28 centimeters was the X, and that's why I'm using it for the X. And then we have to figure out how many 0.04s there are. Well, let's look at them, okay? There's a lot of them, okay? We can count them. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you get one that's got like 5 billion, for example, like you can hardly see the space between them, probably don't want to do that one. Unless you've got a lot of patience, right? Okay, it can still be done. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those guys. I counted it again. I'm such a spaz. This lab is really not a good lab for me to explain to you. Okay, so that was 12, wasn't it? Yeah, so 12 times 0.04 seconds, and now we're ready to calculate something, yeah? Okay, so 0.2 times 10.28 divided by 12 times divided by 0.04, right? Okay, and this is 4.28, and that's kilograms centimeters per second, right? And now let's do the red Y. Why? Because I love you, right? Okay. M-I-C-K-E-Y. Okay, so it's 0.2. What is our red Y distance? 4.82, correct? Yeah? Okay, so 4.82 centimeters. Okay, divided by, and then the good news is it's the same track, so I can use the same number. It's still 12 intervals, right? Yeah? So, we don't have to do everything over again. Okay, so I'm going to do second entry. Do you guys know about second entry on your calculator? Right? I'm just going to go there and edit it. All I need to change is the number at the top is 4.82. So 4.82. And I get 2.01. And that's positive. And that's kilograms, centimeters per second, right? Now let's do, what do we suppose that this momentum is going to be? We think it's going to be negative 2.01 because we know they have to add to 0, right? And that's kind of foreshadowing a little bit there. Okay. Okay. Now blue has a different mass. Remember, blue has a mass of 0.15, right? And then blue after is that was 8.21 centimeters. All right, this is kilograms, centimeters, and then how many intervals is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah? Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14? The 14's a go. Okay? So 14 times 0.04. So 0.15 times 8.21 divided by parentheses 14 times 0.04 end parenthesis. This is 2.20. Yeah? Yeah? Whoops, I should do it in red. I'm missing the thematic. It's actually 2.199, which I'd have to round to 2 sig figs to that, right? And that's kilograms, centimeters per second, right? Okay. I know. It's like an impressionistic kilograms, centimeters per second, all right? Okay. And then the y momentum is going to be 0.15 kilograms. And then the y distance was negative 7.53. That is, it went down, right? So negative 7.53. All right, divided by the same thing, 14 times 0.04. So again, I can go second entry, and all I need to do is change the 8.21 to, oh, darn. Let's see, second insert, negative. Go forward, go back, 7.53. Okay, and I'm getting, and this might be upsetting to some of you, I'm getting negative 2.02 kilograms, centimeters per second, right? It's crazy. So now we're going to add them. We're going to add them like Bonica. Okay? So we add these guys together. This becomes 6.48. Right? This becomes negative 0.01. Okay? Are they about the same? Yeah, they're kind of the same-ish, you know. When you start getting off by more than about, I would say more than about 0.2, you should worry, because let me give you a clue, okay? It's not that they program conservation momentum into interactive physics, but what it does is it integrates forces one object exerts on another, and if you do that, the forces are equal and opposite, therefore momentum's conserved. So it should be conserved. And if you're off by something, double check. In fact, last period, real common things are you miscount the intervals, or you measure, like last period I measured, even though I circled these dots, I measured like from that dot to this dot or something like that. So it's really, really easy to make a mistake. Just double check your calculations. You should be really close. You might not be as close as me because I do have a degree in physics. Actually, you should be closer than me because I'm a spaz. I'm really not very good at this. But that's the deal. If you have to have a group of three, what you need to do is just do 2 images that are different and analyze both images, right? Or one person could just be with you and they analyze their own, you know what I'm saying? Right? But definitely, I definitely don't want a group size bigger than 2 on the lab. Are we good?
Are we doing the chart lab today?
Yeah, you could do either one.